Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to take a look at combined rate problems, which frequently show up on the arithmetic reasoning subtest of the Armed Services Vocational Aptitude Battery. In addition to showing up there frequently, these types of problems also appear on other standardized tests, including the GED, GRE, GMAT, and SAT. So if for some reason you found this video and you're not taking the ASVAB, just bear in mind that this is useful for other standardized tests as well. To start today's video, we're going to briefly review the 2 steps required to solve combined rate problems. And after that, we're going to do practice problems that are 5 variations of combined rate problems. By the end of this video, you should have the sense that you can solve any variation of a combined rate problem you'll see, because as you'll see in just a few minutes, as long as you can manipulate this formula right here algebraically, these problems are very straightforward and easy, in my opinion. So all that said, let's get started. Again, there are 2 steps to solving combined rate problems. The first of which is understanding this formula right here. That is T over A plus T over B equals 1, where T refers to the time working together, A refers to the time it takes for one person or thing to complete the task by themselves, and B refers to the time it takes for one person or thing to complete the task by themselves, respectively. After you write down this formula, you want to adjust it so it's in accordance with what the problem's asking, and then it's just a matter of solving this formula for the missing variables. So just bear in mind that as we work on these practice problems, I'm going to start by writing down this formula as my very first step. After that, I'm going to go back and reread the word problem, make adjustments to this formula accordingly, and then I'm just going to solve for whatever variable is missing. And that's all there is to solving combined rate problems. So all that said, let's get started with the practice problems. All right, so now that we've reviewed that generic formula, let's go ahead and work on some practice problems, which, as I mentioned, are going to require us to manipulate that formula algebraically in order to solve these problems. Question 1 says Walter and Helen are asked to paint a house. Walter can paint the house by himself in 12 hours, and Helen can paint the house by herself in 16 hours. How long would it take to paint the house if they work together? So as I mentioned, the very first thing I'm going to do is write down that generic formula. That is, I'm going to write down T over A plus T over B equals 1. In this case, it should be obvious that A and B refer to the times it takes each person to paint the house by themselves. So I'm going to let A refer to Walter and B refer to Helen. And as we can see in this problem, Walter takes 12 hours to paint the house and Helen takes 16 hours to paint the house. So let's plug those in for A and B. This becomes T over A is Walter, so we know this is going to be 12, and T over B, which is Helen, and she takes 16 hours to paint the house, and of course this all equals 1. In this case, it should also be pretty obvious that T refers to the amount of time it takes both of them working together to paint the house. And since that's what we're trying to solve for, that's going to be our unknown variable for which we're solving. So we're not going to make any adjustments for T. So as you can see, we've adjusted this generic formula to be in accordance with what the problem's asking. And now we just have to solve the equation that we've created. As you can see, we're adding 2 fractions here, notably T over 16 plus T over 12. In order to add these fractions, you may recall that we need to have a common denominator. And in this case, it might be helpful to list out factors in order to find that common denominator. So let's list out the factors of 12, 12, 24, 36, and 48. Factors of 16 are 16, 32, and 48. So as we can see, 12 and 16 have a common denominator, a common factor of 48. So that's going to be our common denominator. So let's go ahead and get this set up with a common denominator. Again, we know it's going to be 48. Now, in order to rewrite this fraction, that is t over 12, to be over 48, you can see that we have to multiply 12 by 4. And what we do to the denominator, we also have to do to the numerator as well. 4 times 12, of course, is 48. 4 times t is 4t. In order to make this 16 a 48, it should be obvious that we multiply it by 3. What we do to the denominator, we also have to do to the numerator. 16 times 3 is 48. 3 times t is 3t. Okay, so now we can add these fractions. That is, we can do 4t plus 3t over 48 equals 1. Again, when you add fractions, you just add the numerators and keep the denominator the same, which you can see I just did right there. Now we're trying to solve for t by itself. The next thing I want to do is combine these like terms of 4t and 3t. So this just becomes 7t over 48 equals 1. Again, we want to solve for t, so that means we want to get t equal to something by itself, which means we're going to have to isolate t. So the next thing I'm going to do is multiply both sides by 48. In doing so, that's going to cross out, leaving me with just 7t over here. 1 times 48, of course, is 48. Now again, we almost have t isolated, but we're going to have to divide both sides by 7. This will give us t equals 48 over 7. In case it's not obvious, you have to treat fractions as long division. So instead of reading this as 48 over 7, you can also read this as 48 divided by 7. And by solving this using long division, we'll figure out exactly what t is. Okay, so now the question is, how many times does 7 go into 48 without going over? That's going to be 6 times, given that 7 times 6 is 42. 48 minus 42 is 6. 7 doesn't go into 6, so we have to add a 0 here. In doing so, that's going to prompt us to bring a decimal up there. 7 goes into 60 8 times without going over. 7 times 8 is 56. Subtract. 60 minus 56 is 4. Again, we have an imaginary 0 we can drop down. 7 goes into 40 5 times without going over. 7 times 5 is 35. And as we can see, this one's going to have a long remainder. So we're going to stop right there. And let's go ahead and round this. We're going to round this tens place, which is the 8. Since this is a 5, we know this will kick this up to a 9. So we can see if Walter and Helen work together, it will take them approximately 6.9 hours to paint the house. Okay? And again, wrote down the generic formula, adjusted the generic formula to match the word problem, solved for my missing variable, and that was pretty much it. All right, so let's look at question 2. Question 2 says, Tom and Jerry have to stuff and mail 1,000 envelopes for a new marketing campaign. Jerry can do the job alone in 6 hours. If Tom helps, they can get the job done in 4 hours. How long would it take Tom to do the job by himself? So again, to start, I'm simply going to write down that generic formula. Again, T over A plus T over B equals 1. This is the foundation upon which you can build an equation to solve these tricky word problems. And this one's pretty tricky. So in this case, we have to identify what we have. We know Jerry can do the job alone in 6 hours. So let's let Jerry be A, okay? And if Jerry's A, that means Tom is going to be B. Similarly, in this problem, we're told that if Tom helps, they can get the job done in 4 hours. So they gave us our T. Again, working together is T. Okay? So in this case, we're going to plug in what we have and then try to solve for what we don't have. So again, we know that working together, they can do the job in 4 hours. So T is going to be 4 hours. So let's plug that in to start. That's going to be 4 in place of T there. Let me rewrite that. And 4 in place of T there. Of course, this equals 1. All right. We know Jerry can do the job by himself in 6 hours. Jerry refers to A. So let's plug in 6 in place of A. And we don't know how long it takes Tom to do the job by himself. In fact, that's what we're being asked. How long would it take Tom, B, to do the job by himself? So we're just going to let B be the variable for which we're solving. Okay? So now that we've written down the generic formula and made adjustments so that it's in accordance with the word problem, all we do is have to solve this one for the variable B, and we'll have our answer. So as you can see, we're solving for B, but that said, we have the addition of two fractions here. We have 4 over 6 plus 4 over B equal to 1. In order to add these fractions, we have to place them over a common denominator. In this case, that common denominator is going to be 6b. So let's go ahead and see how we're going to do that. To make 6b, all I have to do is multiply 6 by b. What I do to the denominator, I'm also going to do to the numerator of this fraction. So 6 times b is 6b. 4 times b is 4b. Okay. In order to make this denominator 6b, I have to multiply it by 6. Again, given that 6 times b is 6b. What I do to the denominator, I'm also going to do to the numerator. So this is going to be 6 times b, which is 6b, 4 times 6, which is 24. Okay. So now we can add these fractions accordingly. This becomes 4b plus 24 equals 1 all over 6b. Again, we're solving for b, so our goal is to get b by itself. That said, we want to get rid of this fraction here, and in order to do that, we can multiply both sides by 6b. This is going to cross out, leaving us with 4b plus 24 equals 1 times 6b, which is just 6b. Again, anything times 1 is itself. Now we're just solving for b. The easiest way to do that is to subtract 4b from both sides. This crosses out, leaving us with 24 on this side equals 6b minus 4b is 2b. Again, we're trying to solve for b, so we want to get b equal to something by itself. So we're going to divide both sides by 2 as our next step. This crosses out, leaving us with just b on this side. 24 divided by 2, we should know is 12. And in math, it's customary to write the variable for which you solved on the left. So this is b equals 12. Again, b refers to the time it takes Tom to stuff and mail the 1,000 envelopes by himself. So in other words, it would take Tom 12 hours if he was working by himself to stuff and mail the 1,000 envelopes for the marketing campaign. Okay, so again, I started by writing down the generic formula. I adjusted it accordingly, and then I just solved for the missing variable. And again, that's all you have to do for these. All right, question 3 says, one pipe can fill a swimming pool in 10 hours, while another pipe can empty the pool in 15 hours. How long would it take to fill the pool if both pipes were accidentally left open? Not surprisingly, I'm going to start this problem by writing down the generic formula. That is T over A plus T over B equals 1. I'm going to identify what information I have in this problem, and then I'm going to make adjustments to this problem accordingly, or this equation accordingly. One pipe can fill the swimming pool in 10 hours. So I'm going to let that pipe be A. Another pipe can empty the pool in 15 hours, so I'm going to let that pipe be B. And the question is, how long will it take them to fill the pool if both pipes were open? So in other words, we're trying to solve for T. That said, in this scenario, we have one pipe filling up the pool and another pipe emptying the pool. So instead of being T over A plus T over B, it should be clear that this has to become T over A minus T over B. Again, this T over A is the pipe filling up the pool, and this T over B is the pipe emptying the pool, or taking water out of the pool. So again, instead of using addition in the generic formula, we're going to rewrite it such that it uses subtraction, which again mirrors what's being asked in this problem. Now let's fill in our values accordingly. This is going to be T over A is 10 hours minus T over B is 15 hours equals 1. Now we're just solving for T, as you can see. In this case, not surprisingly, we have to subtract two fractions, albeit with different denominators. In order to do this, we're going to have to find a common denominator for both of these fractions. And in this case, it's pretty easy. Let's list out factors of 10. That's 10, 20, 30. Factors of 15 are 15 and 30, so that we can see that 30 is going to be our common denominator between these two. So let's go ahead and get that set up. This is going to be equal to 1. Again, to make 10 30, we have to multiply it by 3, and we're going to have to do that to the numerator as well. So 10 times 3 is 30. 3 times t is 3t. To make 15 30, we have to multiply it by 2, and we're going to have to do that to the numerator as well. 15 times 2 is 30. 2 times t is 2t. Okay? Now that we have a common denominator, we can do this subtraction pretty easily. This becomes 3t minus 2t over 30 equals 1. Okay? Again, we're trying to solve for t. So in light of that, our next step is going to be to multiply both sides by 30. This crosses out, leaving us with 3t minus 2t equals 30. Of course, 3t minus 2t is just t. So we can see in this case, t is going to be 30. And in this case, our unit is going to be hours. In other words, if this pump is filling up the pool and this pump is emptying the pool at the same time, it would take 30 hours for these pumps to fill up the pool. Okay, so that was that one. Again, we wrote down the generic formula. We adjusted it. In this case, we went from addition to subtraction since one pump was emptying the pool while another pump was filling it up. We solved for the variable t. And that was it. So pretty straightforward in this case. Question 4 says, one roofer can put a new roof on a house 3 times faster than another. Working together, they can roof a house in 5 days. How long would it take the faster roofer working alone? Okay, so to start, I'm going to go ahead and write down that generic formula. T over A plus T over B equals 1. In this case, let's look at the word problem to see what we're given. Right away, I can see that working together, they can paint the roof they can roof the house in 5 days. So that's going to be our t. In other words, we know t is going to be 5 in this equation. That said, we're not given A and B as we were in the other practice problems in this video. Instead, we're told that one roofer can put a new roof on a house 3 times faster than the other. So if I let A refer to the faster roofer and B refer to the slower roofer. I'm going to say roofer A takes X amount of days to put a roof on a house, which means roofer B, which works 3 times slower than roofer A, will take 3x to put a new roof on the house. And now in place of A and B, I can plug in X and 3x respectively, and then I'll just be solving for X to find out how long it will take the faster roofer to roof the house if he's working alone. So let's go ahead and do that. Again, we know what T is. T is 5 in this case, so this is going to be 5 over X plus 5 over 3x equals 1. Not surprisingly, we now have the addition of two fractions, which we can't do unless they're over a common denominator. So I'm going to go ahead and place both of these fractions over 3x. Okay. In order to make x 3x, I'm going to have to multiply it by 3. More specifically, I'm going to have to multiply its denominator and numerator by 3. 3 times x is 3x. 3 times 5 is 15. This one already has the correct denominator, so we don't have to multiply it by anything. So this is just going to be 5 over 3x. Now we can do this addition. Again, this becomes 15 plus 5 over 3x equals 1. Again, we're solving for x. So as our next step, we want to multiply both sides by 3x. This is going to cross out, leaving us with 15 plus 5, which is 20, equals 1 times 3x, which is just 3x. Again, we want to solve for x, so we're going to divide both sides by 3. This is going to cross out, leaving you with x equals 20 over 3. Again, in this case, we're going to have to regard 20 over 3 as long division, and we're going to read it as 20 divided by 3. And once we work this out, we'll figure out how long it will take this faster roofer to roof the house working alone. 3 goes into 2. It doesn't. 3 goes into 20 6 times without going over. 3 times 6 is 18. 20 minus 18 is going to be 2. Let's add a 0 since we know 3 doesn't go into 2. When we add that 0, we have to bring up a decimal. 3 goes into 20 6 times without going over. 3 times 6 is 18. 20 minus 18 is 2. Now we have an imaginary 0 that we can add. And we should see that this decimal is going to be 66666 repeating, which we should know is the same as 6 and 2/3. In other words, x equals 6 and 2/3 in this case. In other words, it will take this faster roofer 6 and 2/3 days, if he's working alone, to completely roof the house. Okay, so that was this one. Again, we started by writing down our generic formula. Then we identified what we had. In this case, we were given T. We were also given A and B. That said, we had to use some minor algebra adjustments. We had to use this basic algebra in order to represent A and B. Once we did that, we plugged everything into the generic equation and solved for the missing variable. Okay, so that was it for this one. All right, question 5 says, triplets Justin, Jason, and Jacob are working on a school project. Justin can complete the project by himself in 6 hours. Jason can complete the project by himself in 9 hours. And Jacob can complete the project by himself in 8 hours. How long would it take the triplets to complete the project if they work together? Okay, so to start, I'm going to write down the generic formula. That is T over A plus T over B equals 1. And there's a reason I left a space there. So in this case, we have 3 people working together. So the first adjustment I'm going to make to this generic formula is to account for that third person. I'm going to write that as T over C. Okay? So now I got Justin here, which I'm going to let Justin be A. Jason here, I'm going to let Jason be B. and Jacob B, C. So as you can see, I made an adjustment to the generic formula to mirror what's in the word problem. In this case, we're trying to figure out how long it would take them working together to complete the project. So we know t is going to be the variable for which we're solving. Apart from that, we're given information about how long it takes them to complete the project individually. Again, Justin does it in 6 hours, so we know A is going to be 6. Jason can do it in 9 hours, so we know B is going to be 9. And Jacob can do it in 8 hours, so we know C is going to be 8. So let's go ahead and plug those values in and then solve. Again, T is what we're solving for, so we're going to leave that as is. A is 6 plus T. B is 9 plus T. C is 8. Okay. At this point, it should be obvious that the only thing we have to do is place these fractions over a common denominator and then solve for the variable t. All right, so at this point, we can see that we have to add all of these fractions together. In order to add fractions, they have to have the same denominator or a common denominator. In this case, it should be obvious that 6, 9, and 8 have a common denominator of 72. And I'm not going to work that off to the side, but I will talk about that in a second. So let's go ahead and get this one set up. 6 times 12 will give you 72. So in order to make 6 72, we're going to multiply that by 12 as well as its numerator by 12. This becomes 12 times 6, which is 72. 12 times t is 12t. To make 9 72, we have to multiply it by 8. So we're going to multiply 9 by 8 as well as its numerator. 9 times 8 is 72. 8 times t is 8t. To make 8 72, we have to multiply that by 9, and we're going to have to do that to the numerator as well. 8 times 9 is 72. 9 times t is 9t. Okay, now that we have a common denominator, we can simply add all the numerators. So this becomes 12t plus 8t plus 9t all over 72 equals 1. Okay. At this point, you can either get rid of this fraction first, or you can combine all the like terms in the numerator. Let's go ahead and combine the like terms. 12t plus 8t is going to be 20t, plus 9t is 29t. Again, this is over 72 equals 1. Let's get rid of this 72 by multiplying both sides by 72. This is going to cross out, leaving us with 29. And I'm running out of space here. 29t equals 1 times 72, which is just 72. To solve for t, we're going to divide both sides by 29. This is going to cross out, leaving us with t equals 72 divided by 29. So at this point, we can see that we have t equals 72 divided by 29. So let's go ahead and solve that. Again, that's 72 divided by 29. In this case, if we regard 29 as 30, we should see that 30 times 2 will give you 60, whereas 30 times 3 will give you 90. So we know 29 can only go into 72 at most 2 times without going over. 29 times 2, and let's work that out. 9 times 2 is 18, carry your 1. 2 times 2 is 4, plus 1 is 5. So 2 times 29 is going to be 58. Let's subtract. 2 minus 8 we can't do. We're going to have to borrow. This is going to become 6, whereas this is going to become 12. 8, 9, 10, 11, 12. 12 minus 8 is 4. 6 minus 5 is 1. Now the question is, how many times does 29 go into 14 without going over? It doesn't. It's too small, so I have to add a 0. By adding that 0, I'm going to have to add a decimal there accordingly. And in this case, it's also going to be helpful to regard 29 as 30 again, so that we can estimate how many times 29 goes into 140. 30 times 5 would give you 150, whereas 30 times 4 would give you 120. So we know that this is going to go into 140, a max number of 4 times. So this is going to be 29 times 4. 9 times 4 is 36. Carry your 3. 4 times 2 is 8. 9, 10, 11. Okay, so 29 times 4 is 116. Let's do this one more iteration so we can round this tens place accordingly. 0 minus 6 we can't do. We have to borrow. This becomes 3. This becomes 10. 10 minus 6 is going to be 4. 3 minus 1 is 2. And then 1 minus 1 is 0. We have an imaginary 0 that we can bring down without having to adjust the decimal. Now the question is, how many times does 29 go into 240 without going over? If using estimation we regard 29 as 30, we would know that 30 times 8 would give us 240 evenly. So I know 29 is going to go into 240 8 times without going over. It's going to be 29 times 8. 9 times 8 is 72. Carry your 7. And that came out bad. Let me fix that real quick. 2 times 8 is 16, 17, 18, 19, 20, 21, 22, 23. So we can see that this is 232. 29 times 8 is 232. Again, that's the last iteration we're going to do. Using this 8, I can bump up this 4 to a 5. So this is 2.5. In other words, if all these twins work together on the school project, it will take them 2.5 hours to complete it. Okay? And again, I started with the generic formula. I made adjustments to the generic formula to represent what's being asked in the word problem. And then I solved for the missing variable, which was t in this case. Okay? So that's it for today's video. I hope you found it helpful. Again, as I mentioned, in order to solve these combined rate problems, you have to start with this generic formula. You have to adjust it accordingly and then solve for any missing variables. And again, in doing so, you can solve any of these combined rate problems pretty easily. If you like the content I'm creating, please consider subscribing to my channel. Once I finish making videos for the ASVAB, I anticipate creating videos for the SAT and GED as well. So just bear in mind that that is what the future of this channel is probably going to be. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.